So the goal for today, we're jumping right into Unit 5, which is called Introduction to Exponential Functions. But before even getting into what those are and vocabulary and all that stuff, the goal for today and the success criteria is very simple. So it's let's choose the better deal. And you'll know you're successful if you can compare growth patterns using calculations and graphs. So I record all the lessons and I put them in the slideshow that I'm currently showing you. The slideshows have the dates on them and they're in Schoology. So if you're ever absent or if you maybe weren't paying attention, whatever the case, check Schoology and watch the video lesson. It's also a great review material too, if you need a refresher. Some of the units are really long, like I think in this one, there's more than 20 lessons. So it's nice to go back and use it as a study tool as well. The practice will be a puzzle piece. Normal procedures as always. I don't think there's anyone new in this class, at least they haven't shown up yet. So you guys know you get 2 attempts automatically. You can see your attempt, or at least you should be able to. If you can't, let me know and I'll make it viewable. And then see what you did wrong and use your second attempt. If you still think you need another attempt after that, you can always ask. I almost always say yes. The only time I say no is if I think you're just guessing. So if I see that you only spent like 30 seconds on the assignment, I'm not going to give you another attempt. And I can see how long you spent on it. So don't do that. Spend a decent amount of time on it, really try, and then if you want a third attempt, that's fine by me. Also, and this will probably be the last time I talk about this, it'll be in the first day slideshow if you ever want to refer back to it. But this is the extra credit opportunity for the semester. So last semester, it was to make a tissue box introducing yourself. This semester, it's to research whatever college you want and make a tissue box with those facts. And if you need to see like what's required, here's a link to the requirements and also like how much additional extra credit points you could get. So really there's like 15, maybe more, because I still need to count the project itself as some assessment points. But yeah, so you can do this up to like the last day of school. I'll accept it for an extra credit opportunity. And that's probably going to be the last time I talk about it unless you ask. So also in the slides, I always include the upcoming assessments and deadlines. So, and I always highlight the ones that are like the closest to us. You already had a quiz over the syllabus. If you didn't do that, maybe you were absent or your computer wasn't working, whatever, make sure you do. It's not in the lockdown. It's not password protected. You have unlimited attempts. You should all be getting 100% on that. But then like the first real quiz over math related topics will be Tuesday, and it's just over 2 lessons. So if you have questions, make sure you ask, preferably in class, but also through email works if you get home and do your homework and have questions. So any questions about like procedures, all that? Good? All right. And just for like the video's sake, here is the answer to the warm-up. All right. If each bacteria splits into 3 each hour, we have 9 in hour 2 and 27 in hour 3. All right. But now on to today's activity. So the let's choose the better deal is referring to this situation. Make sure you're doing the time. You are walking along a beach and your toe hits something hard. You reach down, grab onto a handle and pull out a lamp. It is sandy. You start to brush it off with your towel. Poof, a genie appears. He tells you, thank you for freeing me from that bottle. I was getting claustrophobic. You can choose one of these purses as a reward. Purse A contains $1,000 today. If you leave it alone, it will contain $1,200 tomorrow by magic. The next day, it will have $1,400. This pattern of $200 additional per day will continue. Or you have purse B, which contains 1 penny today. Leave that penny in there because tomorrow it'll magically turn into 2 pennies. The next day there will be 4 pennies. The amount in the purse will continue to double each day. So just after reading those descriptions, we're going to take a poll. So raise your hand if you think purse A sounds like the better option. Okay, so 1, 2, 3, 4, 5, 6. Okay, I counted 6 people for purse A. What about purse B? Raise your hand if you think that one sounds like a better option. Okay, I counted 4. Maybe 5. There's tons more people in here than that, but it's okay. Just right now, it's just a general poll. Which one you think sounds better? Now you're going to figure out which one is better. So start with number 1. It says how much money will be in each purse after a week and then after 2 weeks. So figure that out within your groups. I'll give you 2 minutes to start. If you need to divide out the work, maybe one person does purse A, the other one does purse B, and then you compare, then that's a good strategy. Otherwise, figure out how much would be in each purse after 1 week and then after 2 weeks. All right, so let's just see. And if you don't know or you get the wrong answer, it's fine. I can walk you through it or give you more hints. But let's just start with table 1. For purse A, how much will be in it after 1 week? Okay, 2,400. Anyone disagree with that? Or get something different? Ryan? See, that's what we ran into as an issue earlier when we did this problem. Even I thought 1,000 would be day 1, but if you look at the textbook, day 0 is when it starts with the 1,000. So that's like its initial amount is the 1,000. So that would be day 0. All right. Anyone get a different answer though for purse A, the $2,400? Okay. So let's see. If that 1,000 is day 0, then that means the 1,200 is day 1. So that's after 1 day. So that kind of makes sense. Like after 1 week, after 7 whole days, that's what it might have. So day 1 would be the 1,200. Day 2 would be the 1,400, and then we can make a table for the rest. So day 3 would be how much? It's growing by 200 each day. 1,600 actually, because it was 1,400 on day 2. So don't count the initial amount as day 1. So after 1 day, it's 1,200. After day 2 is 1,400. After day 3 is 1,600. What about after 4 days? 1,800. 5 days, 2,000. 6 days, and then 7 days. 2,400, and that's how many days are in a week. So that is correct. The 2,400 for purse A after 1 week. Did anyone do it a different way? Or did you all basically just add 200 until you got 7 days?
I mean, I added 1,400. That's the stuff.
Oh, so instead of, well, how did you know to double it?
Oh,
Oh, okay, so you're saying what you got for 2 weeks. Okay, I meant, did anyone do it differently for figuring out the 1 week? Or did you all just add 200 each time, right?
14.
For 1 week, for 1 week, you times 200 by 7, right? Because that's what it's growing by each day, which gives me 1,400. So what would I do after multiplying that? Add whatever you started with, which was the 1,000. That's how another way you could get to 2,400 instead of just adding 200 each time. Okay, questions there? So then, what about for purse B? Let's do table 3. For purse B, how much is in there after 1 week? Okay, $1.28. Anyone get something different from that? All right, so then let's see. For purse B, that one doubles each day. So day 0 will be our starting amount. That doesn't count as day 1. So day 0 is 1 penny. After 1 day, it turns into 2 pennies. So that's my day 1. 4 pennies is my day 2. And we can make a table for the rest. How many pennies do I have for day 3? 8 pennies, because 4 times 2 is 8. I'm going to write it in like dollar form. All right, real quick. All right, sorry. So back to this. On day 4, how many pennies do we have? 16, because 8 times 2 is 16. I'm writing it in dollar amount though, so we can compare. On day 5, how much do I have? 32 cents. Table 5, how much do I have on day 6? That's right. So how much do you have on day 6? 64 cents. And table 6, how much do we have on day 7? $1.28 or 128 cents. All right, so then when you're comparing just after 1 week, which purse is the better option? Purse A, and that one we have 2,400, whereas in purse B we have $1.28. Now after 2 weeks, or real quick, did anyone have a better way of solving for purse B, or did you just double it each time, like you just times 2 each time? Yes. So an exponent, because we're timesing 2 each time, right? So what are we starting with for purse B? We're starting with 1 penny, right? I'll just put 1. Yeah, we put it in dollar amounts over here, but I'm just gonna put 1. And then we're timesing it by 2 for a total of 7 days. So that's 1, 2, 3, 4, 5, 6, 7. Another way to write that would be 1 times 2 to the 7th power. Isn't that the same thing? Yes. And when you're multiplying just straight across, it really doesn't matter. Like you could like do the second half first. So you could work that out and then multiply it by the 1. So that's another way you could get the 128, which of course we converted to a dollar amount by just like dividing 100. So definitely in this unit, you need a calculator. I don't know 2 to the 7th power in my head. And there's going to be exponents that are going to be a lot harder. So that's why you need to know how to use a calculator. Can you what? Yes. All right, so keep that in mind too. So you could just keep timesing by 2 until you get up to the same number of days. But what if it asks you how much is in there after 100 days? Is that like really feasible or something that you want to do? Maybe not. So now let's look at 2 weeks. If you do not have the answer for after 2 weeks, try using the methods we did in red real quick. Give you 1 minute to do that. All right, table 2, how much is in purse A after 2 weeks? No answer. Well, if you don't know, look at what we did for purse A for the 1 week. How many days are in 1 week? How many days are in 2 weeks? 14. So maybe if we use that same process, just change the number of days, because that's the only difference in the situation now, is the number of days. You should be able to figure that out. Because it's 200 additional each day, plus what we started with. So now what's the answer? All right, I don't have my answer key ready, so let me just do it real quick. 200 times 14 plus the 1,000. Right, yeah, 3,800. Like you could also just keep adding 200 each day, but again, that may or may not be feasible. So that's what we have in purse A after 2 weeks. Table 5, what do we have in purse B after 2 weeks? Penny. All right, anyone get something different than that?
Yeah. Oh, I know, $40 and 60.
Okay, $40. I don't even remember the answer right now. So here's what you can do. You could times 2, you could keep working this table all the way to 14 days. Because that's how many is in each day. So doubling is timesing by 2. Or if you can figure out the expression, that could save you a lot of time. What did purse B start with? 1 penny. And I'll just put it in the form of pennies and then we'll convert it to dollars later. So 1 penny and we're timesing it by 2. How many times in this one? 14. How could I write that instead of doing times 2 times 2 times 2? I could do 1 times 2 to the 14th power. That would be a lot better than writing it 14 times. So that's really the only difference between these two processes. Same initial amount, same thing we're multiplying each time, just a different number of days. So if you put that in your calculator, let's see what we get. If you're using Desmos as a calculator, you could just type in the number, the base number, and then use this button, and then type in the exponent. So 14 is our exponent. And that's how many pennies we have. If we want to convert that to dollars, what would we do with that number? Divide it by 100. So 16,384 pennies divided by 100 gives us a dollar amount. So no one got it right, but that's how you could get it. Unless you got it right and you just didn't speak up, but that's how much is in purse B after 14 days. And I didn't show you the times by 1, but hopefully you know that when you times by 1, it's just that number. So there you go. All right. 163.84. So fill that in and show your work for how we got that. All right, we're gonna skip number 2 because, you know, time. I'd rather you have some time to work on your practice. Now let's do number 3 if you haven't already. if I wanna know how much is in each purse after 30 days, what would I do for purse A?
Uh,
Good, 200 times 30 plus 1,000 plus what we started with in that purse. So do that. What's the answer for after 30 days? 7,000 is correct. If you don't believe me, feel free to check it. I do remember that. Now for purse B, remember that's the one that doubles each day. So it has a different expression. It can be modeled by this, except for what would be different in this one, the 30 days.
14 would be 30.
Where the 14 is would now be a 30. So here's my starting amount times 2, basically 30 times. So we're timesing 2 by itself 30 times. So that's also like saying to the power of 30, which is a really big number. All right, it's a really big number. And I know that because my calculator doesn't even want to show it all to me. It shows me it in scientific notation. Scientific notation, if you ever see that, if it's times 10 to a positive number, you move the decimal to the right that many times. So in this one, I would move it 9 times, which would end up being here. And that's how many pennies I have. But if we want to put it in a dollar amount, which I think you should, especially if you're going to compare it and see which one is better. So I have 107, 37, 418, 24 divided by 100. That's how much money is in purse B after 30 days. So that number is 10,737,418.24. All right, so now which purse would be the best deal after 30 days? Purse B. Because it increases at a lot faster rate than purse A. So I guess it really just depends on how long you're going to not touch that money. Questions on this part of the activity? All right, so timesing something each time will most likely, I would say like 99% of the time, supersede adding the same amount each day. So if you look at this graph on your paper, this is that situation. The same situation. So the red line would represent purse A or purse B. Purse A, how do you know? Because it's going up by a consistent amount each day. So that means the blue one must be purse B. And that kind of makes sense. Like once you start getting to bigger numbers, the amount it doubles grows at a lot faster rate than purse A. Let's talk about the vertical intercept. What's another name for vertical intercept? Your y-intercept. So this question is asking what are the coordinates of my y-intercept for each graph. So for purse A, I know it's probably hard to read on this, but what's my starting amount in purse A? From the problem. 1,000. That's the amount of money in dollars it has. So purse A, that coordinate would be 0, 1,000. All right, so the 1,000 is my y value, and your y-intercept is when x is 0. That's my starting amount. For purse B, what amount did we start with? 1 penny, and it wants it written in like dollar form. because it says amount in dollars. So that coordinate would be then what? 0, 0.01. Or 0.01, yes. That's my X, that's my Y of my first B Y intercept. Good there? So that, the rest of the questions we answered when we discussed. But if you didn't choose first B, put that in for number 5. Even if you still think first A, because maybe you would touch it after a week, I don't know, whatever. The whole point of this lesson is to choose a better deal, and really first B is the better deal because it grows at a much faster rate than first A. So questions, comments, concerns? All right, then that gives you plenty of time, a lot more than my first hour had, to work on your puzzle piece for today. It's not very long. So get it done now so that way you don't have homework. It's a blue one in Schoology and it's the 5.1 practice.